Now, in this uh, lecture, I will discuss on an illustrative example on simple impulse turbine, that is the D-level turbine. Now, this is the problem statement. I have taken this problem from one of the examination conducted by Macaut. The paper was on thermal power engineering in the year 2017-18. So this is the problem statement, as you can see. So in an impulse turbine with a single row wheel, the mean diameter of the blades is 1.05 meter and the speed is 3000 rpm. The nozzle angle is 18 degree. The ratio of the blade speed to the steam speed is 0.42, and the ratio of the relative velocity at the outlet from the blades to that at the inlet is 0.84. The outlet angle is to be made 3 degree less than the inlet angle. The steam flow is 10 kg per second. Derive the following quantities: tangential thrust, axial thrust, resultant thrust, power developed, and blading efficiency. Now we will try to understand each and every quantity and try to understand the relation of these with the performance parameters or the quantities that are asked to calculate, that are asked to be calculated. Okay, here I have rewritten the problem statement. You can see. So this is impulse turbine with a single row wheel. Here we have basically one nozzle stage, another is the blade stage, single blade stage. So basically single row wheel, basically one blade row only. Single row wheel means basically even if you consider a velocity compounded impulse turbine, there is basically say 2 row wheel, 3 row wheel, as we have studied. Here it is told that it is single row wheel. So if I just show you the diagram corresponding to the velocity compounded turbine, this terminology comes into picture. That is the row wheel, this that is single row wheel, double row wheel, that uh, nomenclature or that term comes into picture. So you can see that. You see this one. So this is called a 2 row wheel. So as in this wheel, this is called the wheel, this shaded or this hatched component, this is called the wheel. Say this one. So this is called the wheel, this hatched component. And on this, you can see that this green tick 1 and green tick 2, these two are the 2 rows of the blades. So this is called a 2 row wheel. Now in case of single row wheel, that means basically on the wheel there is only one set of row of the blade, and that means that is all. So that is the meaning of single row wheel. Okay. Now so this is a 2 row wheel, and in case of actual velocity compounded impulse turbine that we have studied, that is called, this is a 3 row wheel. As you can see that two green tick, I'm sorry, say this is red tick. I'm extremely sorry. This is red tick. So this red tick, single red, double red, double tick, and triple red tick. These three taken together is called the 3 row wheel. So this is the blade. This is another blade, and this is third one is the uh, third row of the blade. So first, second, and third. So 3 rows of the blade. So this is called a 3 row wheel, and this is called the wheel. In this diagram, I was সো ওকে, সো এইটাতে একটু ভুল বলেছিলাম আগে। দিস ইজ দ্য নজল, না এটা ঠিকই বলেছিলাম, দিস ইজ দ্য নজল অ্যান্ড দিস ইজ দ্য ব্লেড স্টেজ. This is the blade stage. So first row of blade and this is the second row of blade, and in between you have a stator. So this is the nozzle. After that there is a blade. So first row of blade, then again a fixed blade or the stator or the guide fence, and then again another, say another row of blades. So this is called a two row wheel. Why? Because this is a wheel and on this two sets of rows are there, and in between there is a stator or the guide fence. So this is called a row wheel. That means this nomenclature is used in this case, in this type of arrangements or these designs. So in case of three row wheel, similar to that, you see that this is the wheel on which basically there is a arrangement. So this red tick, it is the first row of the blade. Then on this wheel, first row of the blade on the red double tick, this is the second row of the blade, and three double tick, it is the third row of the blade, and in between you can see green ticks. So this is the second stage of the rotor, then sorry, stator. Then the third three double tick green, this is the third stage of the that means the stator. So basically this is the means actually in terms of guidance this is the second one, but in terms of stage it is the third one. So this is the means green double green triple trick and red triple trick taken together is one stage, that is the third stage. So this is double green tick and double red tick, this is basically stage 2, and green tick this is nozzle, and the red tick this is taken together is the first stage. So as you know that in case of a velocity compounded turbine, only one nozzle is there. After that only the fixed blade and moving blades are there. And in case of pressure compounded turbine, each and every stage has one nozzle. There will be expansion. So that should be clearly understood. Okay, now I am going to the problem. Okay, sir. Okay, is it clear? That kind of difference that should be clearly understood. Pressure compounded and velocity compounded. What is the difference? So in case of velocity compounded turbine, there will be only one set of nozzles. All other things are basically guide vanes or fixed blades. There is no nozzle. But in case of pressure compounded turbine, there will be basically expansion in each stage. Therefore, there will be basically nozzles. So the gas or the steam will be passing through the nozzles. Okay. বিশেষ করে টু রো হুইল থ্রি রো হুইল এটা বলা হবে। Yes, yes, yes. In the blade, in the wheel, basically, how many rows of blades are there? Depending on that, it will be a single row wheel, double row wheel, or three row wheel. Okay. 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 Next, I will discuss on the problem, and we will try to identify each and every quantity and regard and related calculations. Here we see that Okay. So mean diameter is given. Mean diameter means what? What is the meaning of mean diameter? You see, again, I'm just showing that diagram, or we may copy that diagram here for convenience. So that is the mean diameter. You can see this line. That is the meaning of mean diameter. So as you can see that this is changing, the area is changing, the blade lengths are changing, but there is a mean diameter. So that is known as the mean diameter. Okay, so this one. So that is the mean diameter. So from this, it is the mean radius. So this is R. This is the mean radius. And accordingly, a double of that will be basically mean diameter. So this is the radius. So this is the mean radius. So for the turbine, this is the mean diameter. So mean diameter is basically required to calculate the blade velocity U. So blade velocity is basically what? R omega. Because this is a rigid body, so it is having a circular motion at at the point of the blade that will have a circular motion, and therefore the velocity is equal to R omega in the meridional plane or in the tangential plane. So let us write the given data. Given data. Mean diameter given. Is equal to, say, dm is equal to, we can write 2 into mean radius is equal to 1.05 meter. Okay. Next, what quantity given? RPM is given. So rotational speed is equal to N is equal to 3000 RPM. Another thing is nozzle angle given. So nozzle angle. What is the name of nozzle angle? Alpha 1. 18 degree. So nozzle angle is same as alpha 1. That is the angle of the absolute velocity of steam at the inlet. Okay. Another thing is given, the ratio of the blade speed to the steam speed is 0.42. That is called the blade speed ratio, as we know. So blade speed ratio. So blade speed ratio is given. As we know, that is called rho. That is called U. That is equal to U by V1. Right? U by V1. Now what is that? 0.42. Another quantity is given as the ratio of the relative velocity at the outlet from the blade to that at the inlet is 0.84. That is called the velocity coefficient. That is K. In earlier discussion, we have termed that as a friction coefficient. It is better to term it as velocity coefficient because the friction coefficient is a misuse of the word, because you see that if friction increases, that should decrease. But here we see that if there is no friction, that VR2 is equal to VR1. So it is better to use velocity coefficient, that is K, as velocity coefficient instead of friction coefficient. So that is the correct word for that. So it is velocity coefficient. Please correct that in the earlier lecture also. Velocity coefficient. Velocity coefficient is equal to K is equal to VR2 by VR1 is equal to 0.84. That means there is some friction. Due to that, at the exit or outlet from the blade, the relative velocity is lower than the relative velocity at the inlet to the blade. So that is a loss due to friction. That is a reduction due to friction. One thing. Another thing that is given is the outlet angle is to be made 3 degrees less than that of that at the inlet. So blade angle at the outlet is B2. So blade angle at the outlet is equal to B2 is equal to B1 minus 3 degree, where B1 is the beta 1 is the blade angle at the inlet. Beta 1 is equal to blade angle at the inlet. Okay. And mass flow rate is given as 10 kg per second. Mass flow rate is given as 10 kg per second is equal to mass flow rate of steam through the turbine. So these are the quantities that are given. Okay. Next, we will try to determine all these quantities: tangential thrust, axial thrust, etc. So, what is the requirement for the from the point of view of calculation of all these? Let me see whether the things are already drawn here. Okay, anyways, let us draw it again. Uh, so if we draw the velocity diagram, as we know that there will be basically a velocity. So if we draw the diagram, uh, that means to the blade, so this is the blade, and there will be velocity of the blade in this direction. Now I am drawing the velocity diagrams accordingly. So at the inlet, this is the velocity at the inlet U. This is the relative velocity, and the actual velocity is this one. So actual velocity name is V1. This is U, and this is VR1, and the names of the angles are, this is alpha 1, this is beta 1, and in the same way there are other quantities. Here you have basically this is U, then at the exit so this is U, and then we have the absolute velocity, that is V2, and accordingly all the angles can be identified. This is VR1, and the angles are, this is beta 2, and this is alpha 2. Okay. Now if we combine these two diagrams, then We have to combine these two diagrams in the same direction. Now we will place one on the other, and that will be the combined diagram. Okay. Now we will just change these names so that they uh, come correctly. Sorry. I'm sorry, this would be VR2. I'm sorry, this is VR2. Extremely sorry. This is VR2, not VR1. This is VR2. So this is VR2. And some other quantities I will just change here. Yes. So this angle is basically, this angle is beta 2, or you can basically show them in the same direction as this one. So it will be, I think, better. Let me redo it. It will be good to follow the same direction of these two. So let us just copy. Okay. So we can shift these so that we can clearly understand that. Okay. Next, so this is therefore VR2 in this direction. So from this VR2, VR2 here, and therefore V2 will be simply this one. This will be simply V2. So this is V2. So VR, this red one is VR2. VR2. This is beta 2, and this is here one. This is beta 1. So this is beta 1. Okay. This is beta 1. And this is beta 2. And this is alpha 1. And this is alpha 2. Alpha 2. So alpha 1, beta 1, alpha 2, beta 2, all are identified. This is U. Okay. Next thing is that we will calculate the quantities. So from this relation, you see, so actually, what is the actual thrust? Tangential thrust. What is that? Tangential thrust means basically what? The tangential component of the force given by the steam. So that is related to what? Tangential thrust is related to delta V W. That is the change of wall component of the steam. Okay. And axial thrust is what? Axial thrust is related to delta V F. We have seen in the last class. So that is the change of the axial component. It is related to, this is not exactly equal to, this is velocity. The tangential thrust is related to velocity multiplied by mass flow rate. So change of the axial component of steam speed. This is speed. So these are velocity and multiplied with mass flow rate, we will get the rate of change of momentum that is equal to the force. And resultant thrust means basically the vectorial addition of tangential thrust and the axial thrust. So what is the meaning? Meaning is that on the blade there is a an axial component of force this is the axial component of force, and there is a tangential component of force. So there is a tangential component of force. So these are the two things there. These are the two things. So axial, this is axial. Gray, it is axial component of force, axial thrust. And the magenta color, it is the tangential or the wall component. This is tangential thrust. So the tangential thrust, as we know, that is equal to m dot fu that we have calculated in the first day. Fu, that is mass flow rate multiplied by the change in velocity in the wall direction that we have calculated. I am just referring so that you can follow. During the calculation of blade efficiency in the first, that is for the single stage, this one. This is the tangential force or the tangential thrust. You can see this is the tangential force or the tangential thrust. This is called the tangential thrust. So this is Fu multiplied by this. Fu is equal to m dot into delta V W. That is the change in velocity multiplied by m dot. So basically what is happening? The steam, when it is passing through the blade or it is impinging on the blade or striking the blade, its momentum is changed. Therefore, in that direction, what is the effective force that the steam is applying or imparting on the blade? That is equal to mass flow rate of the steam multiplied by its change of velocity. That is because that is equal to the rate of change of momentum. So it is mass flow rate into change in velocity. That is nothing but what? That is nothing but the rate of change of momentum. That is nothing but the force from the second law of motion, Newton's second law of motion, rate of change of momentum. in the tangential direction. When you can recall, when you can remember the definition, that is the conceptual part properly, then the problems can be easily solved without any difficulty. Okay, only thing that you have to remember these definitions. You see that you are applying basically mechanics. From engineering mechanics you have studied, that is rate of change, of momentum is equal to the applied force in that direction. So in the particular direction, what is the rate of change of momentum? That is equal to force in that direction. Okay, so you see that uh, the concept of mechanics, how much it is important. Everywhere it will be applied. So you see that all these theories are based on thermodynamics and engineering mechanics mainly. If you have studied well, if you understand the concepts, then you can solve or understand all the theory as well as the problems. At least you can uh, means appreciate the problem. That means how it can be solved. At least you can try that. Okay, so that is the thing. Therefore, axial thrust. First part. Now we will do that. Before that, we will derive certain quantities from this. So what is VV therefore? Sorry, U. U is equal to, here you can see that U is equal to rho into V1. Rho is given and V1 we do not know yet. So we can calculate. So U is equal to rho into V1 is equal to rho means 0.42 into V1. Again, we know that V1 cos alpha 1, you see that V1, this is V1. So V1 cos alpha 1 is equal to VR2 cos beta 1, VR1 cos beta 1 plus U. That we know. So V1 cos alpha 1 is equal to VR1 cos beta 1 plus U. That is from the geometry of the triangles. So V1, we can write cos alpha 1, alpha means 18 degree. So cos 18 degree is equal to VR2. What is VR2? VR1 we do not know yet. So VR1 cos beta 1 plus what is U? U is equal to 0.42 V1. As we know it, cos alpha 1 given. So we can write it. Again, you see that we have written here what is VB. U. U is equal to, here we can write what is U? Basically, U is equal to blade velocity is basically R omega, that is R mean into omega. So what is that? R means basically 1.05 meter by 2 multiplied by omega. Omega means basically RPM. So RPM means basically 3000 divided by 60. right? And multiplied by 2 pi. So 2 pi n by 60, that is omega is equal to basically, you can write it at the top. So omega is equal to twice pi n by 60 radian per second. That is nothing but twice pi into 3000 by 60 radian per second. So 3000 into twice pi by 60. That is radian per second. So that can be calculated to be U is equal to, you can see that this is 50 and this 2 and this 2 will cancel. So it is coming to be 52 pi, 52.5 pi meter per second. That is U. That is blade velocity. Okay. Now another thing is, see that this VR, I want to calculate V1 here. Okay. So you see that what is the relation between V1 and VR1? They are having the same height. For this triangle, if you consider, for this triangle, so this quantity is equal to V1 sine alpha 1 is equal to VR1 sine beta 1. Okay. Now first let us write the tangential thrust. What is that? Then we will calculate the quantities accordingly. Tangential thrust. What is that? Say Fu is equal to mass flow rate multiplied by delta V W. Mass flow rate we know, and delta V W is what? Basically VR1 cos beta 1 plus VR2 cos beta 2. So that is from the velocity triangle. So this is total VW. So from this point, this one. So basically This is delta VW. This one, delta VW. Delta VW, that is nothing but this plus this. So this is basically, this is VR2, this is VR2, and this is beta 2. So this is equal to basically this is VR2 cos beta 2, and this is VR1 cos beta 1. As this red line is VR1 and this angle is beta 1, so this component is VR1 cos beta 1 and this component is VR2 cos beta 2. So total is equal to VR1 cos beta 1 plus VR2 cos beta 2. Okay. So this angle is, you see, this angle is beta 1. Therefore, you see that this red line is VR1 and this angle is beta 1. So this along the tangential direction, it will be cosine of that. And along the axial direction, it will be sine of that. Along the axial direction, the component will be sine of that angle. And along the tangential direction, it will be cosine of that angle, because the angle is taken from the tangential direction. That is why the component will be along the tangential direction, always the component will be cosine of that. And perpendicular to that in the axial direction, it will be it will be sine of that. Okay. Because the angles are taken from the tangential direction, all the angles. ঠিক আছে? ঠিক আছে? হুম, ঠিক ঠিক।
ডেল্টা ভিডব্লিউ যে লিখেছে এটা কি ভি1 প্লাস মানে ভিডব্লিউ1 প্লাস ভিডব্লিউ2 নাকি দুটো ডিফারেন্স?
হ্যাঁ হ্যাঁ, এক্স্যাক্টলি একই 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 VW1 প্লাস VW2। হুম,
দুটো অপোজিট
সেটা VW1 VW2, they are actually different. VW1 VW2 in terms of the component of V1. Okay. VW1 and VW2 are the components of V1 along the wall direction. I have written here in terms of the component of relative velocity, but VW1 or VW2, they are actually component of V1 along the tangential direction, but their sum are same. So either you can write VR1 cos beta 1 plus VR2 cos beta 2, or you can write V1. Basically, in that case, it will be basically VW1 minus VW2 instead of plus.
ডাইরেকশন তো অপোজিট হলে তো প্লাস প্লাস হয়ে যাবে।
হ্যাঁ, এক্স্যাক্টলি, ওইটাই কারণ যে ডাইরেকশনটা অপোজিট বলে ওটা প্লাস হয়ে যাবে, মানে ম্যাগনিটিউডটা বড় হয়ে যাবে, মানে প্লাস হবে, মানে কি ম্যাগনিটিউড ওয়াইজ ইট উইল বি ইনক্রিজড, কিন্তু component wise it will be negative. Okay, এটা change যেহেতু, that is, since it is a change, so we will calculate theoretically as VW1 minus VW2, but since the VW2 is in the opposite direction to that of VW1, that is why, means magnitude wise it will increase, means magnitude wise it will be the magnitude of VW1 and the magnitude of VW2 added. Okay, but theoretically it will be VW1 minus VW2. এটা কিন্তু মিস্টেক করবে না, ঠিক আছে?
ম্যাগনিটিউডটা যেটা হবে সেটা পজিটিভ হবে।
এক্স্যাক্টলি, ম্যাগনিটিউড, এটা ম্যাগনিটিউড অফ দিস উইল বি, এটাকে যদি এইভাবে লিখি, দেখো, ম্যাগনিটিউড অফ দিস উইল বি ইকুয়াল টু ম্যাগনিটিউড অফ VW1 প্লাস ম্যাগনিটিউড অফ VW2, এইটা হবে। যেহেতু এটা অপোজিট ডিরেকশনে আছে, সেই জন্য এই নেগেটিভ নেগেটিভ পজিটিভ হয়ে গিয়ে এটা এটা হবে। কিন্তু থিওরিটিক্যালি তুমি যখন লিখবে চেঞ্জ হিসেবে লিখতে হবে।
হ্যাঁ,
ঠিক আছে,
থিওরিটিক্যালি নেগেটিভ বার করতে হবে।
এখানেও কিন্তু তাই হয়েছে। হিয়ার
আচ্ছা,
অলসো ইট ইজ
এখানে
সেম।
হ্যাঁ,
এই
এখানে
যে
অপোজিট
VW2,
হচ্ছে।
এখানেও আমরা তাই প্লাসটাকে লিখেছি, কারণ ওটা নেগেটিভ নেগেটিভ প্লাস হয়ে গেছে। কারণ দেখো, ভি V1 VR1 ডাইরেকশন আর VR2 ডাইরেকশন, দে আর অপোজিট। In terms of the world component, it is along the movement of the velocity, along the movement of the blade। এই যে VR1 is along the movement of the blade, আর VR2 in the opposite to the movement of the blade, তাই না?
ইয়েস স্যার।
তাই জন্য এটাতেও তাই হয়েছে ব্যাপারটা কনসেপচুয়ালি। এখানে আমরা প্লাস লিখেছি, কিন্তু অ্যাকচুয়ালি ওই মাইনাস আর মাইনাস মাল্টিপ্লাইড হয়ে গিয়ে প্লাস হয়েছে। ঠিক আছে।
আচ্ছা,
হুম।
ঠিক আছে।
তাহলে tangential thrust is equal to this one. So now এটা আমরা ক্যালকুলেট করতে পারবো। তো now for this what we need is basically what we need VR1 beta 1 VR2 beta 2, right? We need this, isn't it? For this we need to calculate this. Now what we know already, m dot we know. Now what is VR1 we will try to calculate. So from this relation what we told that it is VR1 V1 sin alpha 1 is equal to VR1 sin beta 1. So we can write that V1 sin alpha 1 is equal to VR1 sin beta 1. Okay. Then what we can do is we can put this here. You see, if we just mark this in this equation, if we put it, so all in terms of say V1, if we put what it will make in this equation, so it will be V1 cos 18 is equal to what is VR1? From this relation, what we can write VR1? What is that? VR1? VR1 is equal to V1 multiplied by sine alpha 1 by sine beta 1. Then we can put it here. Therefore, what is VR1 cos beta 1? Therefore, what is VR1 cos beta 1? কি হবে? এটাকে cos beta 1 দিয়ে মাল্টিপ্লাই করে দিই, তাহলে এটা হয়ে যাবে V1 cos beta 1 sin beta 1, it will be sin alpha 1 by tan beta 1. Right. So here it will be alpha 1 basically 18 degree. So here therefore it will VR1 cos beta 1 is equal to V1 sin 18 degree divided by tan beta 1 plus 0.42 V1. Okay. Now we see that here in all the terms there is V1. So you can basically cancel that. So from this, it is written here. So therefore we can write, that means basically cos 18 degree is equal to sin 18 degree by tan beta 1 plus 0.42. So from this, we can calculate tan beta 1. Tan beta 1, it can be calculated. That is coming to be 0.58189. And therefore beta 1 can be written as tan inverse of that. That is coming to be 30.19 degree. Tan inverse of that. So beta 1 is this. Okay. So beta 1 we have got in this term beta 1. What is beta 2 therefore? Beta 2 is told that beta 2 is beta 1 minus 3 degree. So therefore we can write from this. Therefore এইটাকে আমি একটু পিছিয়ে নিয়ে যাই। হ্যাঁ, therefore what is beta 2? Beta 2 is equal to beta 2 beta 1 minus 3 degree is equal to 27.19, isn't it? 27.19. So beta 1 also we have got. Sorry, beta 2 also we have got. Right. So here we see that what are required. Now can we calculate this quantity? Can we calculate this quantity? Please tell. We can calculate this quantity because you see that here VR1 is known. VR1 we have not yet determined. VR1 we have to determine. So VR1 is what? We know V1. Here what is known? In this term VR no VR1 we can determine VR1. You see what is VR1? Is it VR1 this quantity from this relation? This is one important relation. এই যে ইউ তো বেরিয়েছে, ইউ দ্যাট ইউ উই নো। এই যে
ভিআর ওয়ান তোমার থেকে পেয়ে যাবে, হ্যাঁ ভিআর ওয়ান তোমার থেকে পেয়ে যাবে, কেটা ইউজ করে ভিআর টু পেয়ে যাবে।
এই যে রাইট, ইউ উই নো, ইউ উই নো, rho we know, so we can determine what is v1, right? So what is v1? Therefore v vr vr1 is equal to, from this relation, is equal to v1 sin alpha 1 by sin beta 1, v1 sin alpha 1 by sin beta 1. Now what is v1? v1 is equal to rho into u. I'm sorry, u by rho. v1 is equal to u by rho. v1 is equal to u by rho multiplied by sin alpha 1 by sin beta 1. So all these quantities are known. All these quantities are known, right? U we know, here you see U we know, rho is 0.42 given, alpha 1 is 18 degree, beta 1 is 30.9 degree. So you can determine all this, and therefore just putting the values you can determine what is VR1. Okay, is it clear?
Yes, sir.
So VR1 is coming to be 2, from this, if we put all the values, VR1 is coming to be 241.32.
সেকেন্ড স্যার।
হ্যাঁ, মিটার পার সেকেন্ড। मीटर पर सेकंड, राइट, ওটা লিখতে হতো, ঠিক আছে। मीटर पर सेकंड। Next, so therefore axial thrust is equal to, Fu is equal to, mass flow rate is known, 10 kg per second multiplied by, now you see that I need not calculate VR2 here, because I know VR1, I know what is the ratio of VR2 and VR1. So that can be easily calculated here. So if I just take out VR1, then I can write this as cos beta 1 plus VR2 by VR1, that is K, multiplied by cos beta 2 multiplied by VR1. So if you like, then I can erase it, and then I can write VR2 by VR1, and then in the next step you can write what is that. So that is equal to 10 cos beta 1 plus K cos beta 2 into VR1. So here you can just put the values and you can determine the tangential thrust. So 10 multiplied by cos beta 1, cos of 30.19 degrees plus K is 0.84 given, multiplied by cos beta 2, 27.19 degrees, multiplied by VR1 is coming to be 240, multiplied by 241.32. What is the unit? Unit should be newtons. So it is coming to be 3,888. You please calculate yourself and verify the numerical values. 97 newtons. So tangential thrust Fu is equal to this much newtons. Tangential thrust. So part 1 is completed. So that is part 1. Part 1 of the problem, tangential thrust. Next, axial thrust. What is that? How to determine the axial thrust? Axial thrust is, as I have told, that m dot multiplied by delta Vf, delta Vf. So basically, what is that? You see that here, as we have added the cosine components, in case of axial component, the sine components will be subtracted. You see that what is that? Vr, it will be basically axial component. That is, this is that you see that either it is V1 sine alpha 1 or VR1 sine beta 1, and for this it is how much? This one, this is V2 sine alpha 2 is equal to VR2 sine beta 2. This one. Therefore, in the axial direction, it is coming with VR1 sine beta 1 and leaving with VR2 sine beta 2. Therefore, the effective thrust in the axial direction or effective change of momentum in the axial direction is equal to mass flow rate multiplied by delta Vf simply. So that is equal to mass flow rate multiplied by VR1 sine beta 1 minus VR2 sine beta 2. You could write in terms of alpha 1, alpha 2 also. That will be same as that. So it will be basically same as, in bracket I am writing, same as m dot multiplied by, that means delta Vf is same as V1 sine alpha 1 minus V2 sine alpha 2. This is same as that one. Okay. So it is negative because they are in the same direction. But in case of tangential component, they are opposite. But the sine components or the axial components, they are same. Okay, in the same direction. That is why they are subtracted instead of being added. That should be kept in mind. So therefore, we
axial component x to the same হবে axial component x to the same
direction they are same because that is why they are entering and leaving, isn't it?
হ্যাঁ সেম ডিরেকশন ওটা তো কোনো চেঞ্জ হচ্ছে না ওটা তো
না রাইট রাইট অ্যাক্সিয়াল কম্পোনেন্টে একই ডাইরেকশন হবে, দুটো একই ডাইরেকশন হবে।
একই ডাইরেকশন
So it will, we know all the quantities, therefore we can determine what is the axial thrust. So axial thrust is equal to m dot, we know 10 kg per second. Now VR1, again sine beta 1, we know sine 30.19 degrees minus, again it will be k multiplied by sine beta. Sine beta 2 means 27.19 degrees multiplied by 240, that is VR1, 242, or you can write here, right? 2.2, 242.3 to 241.32. That is basically 10 multiplied by, okay, you calculate, put the value of k is equal to 0.84 and calculate it. It is coming to be 287. 28 newtons. So axial thrust.
VR1 sin beta 1 minus VR2 sin beta 2 এইটা ডেল্টা ভিএফ টা কি করে হচ্ছে এটা আমি বলুন তো
এটা axial direction a change of velocity delta vf. Axial direction a change of velocity
আপনি
is,
তো শেষেরটা শুধু দেখালেন যে শেষে
axial direction a change of velocity তো এটা হচ্ছে এটা হচ্ছে VR2 cos beta 2, এই VR2 sin beta 2, এইটা এই যে এইটা, you follow the marker, can you follow the marker arrow, that is the cursor,
ইয়েস স্যার ইয়েস স্যার
এই যে red cursor, this is V2 sin beta 2, V2 sin alpha 2, or VR2 sin beta 2, they are same. So this is the height. Basically, what is the meaning of delta VF? Delta VF meaning means that the change in height of the triangle. So এখানে triangle এর height কত ছিল? The height of the triangle, that is the axial direction. The height of the triangle is in the axial direction. So the delta VF means the change of axial velocity. Therefore, that is the change in the height of the triangle. So that is VR1 sin beta 1, and here it is
VR1 sin beta 1
VR2 sin beta 2. So that is the change is equal to VR1 sin beta 1 minus VR2 sin beta 2. Okay,
হ্যাঁ
clear?
হ্যাঁ হ্যাঁ আচ্ছা আর 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 আরেকটা যেটা বললেন ওটা সাইন আলফা টু রেসপেক্টেড
হ্যাঁ, এটা সাইন আলফা দিয়েও করতে পারা যায় একইভাবে, কিন্তু আমরা তো আলফা টুটা আমরা ক্যালকুলেট করিনি, আলফা টুটা আমরা জানি না, তাহলে আবার ওই ট্রায়াঙ্গেল দিয়ে আমাকে এটাকে আলাদা করে আমাকে ক্যালকুলেট করতে হবে, বুঝতে পারছো? ইফ আই ওয়ান্ট টু ইউজ দিস ফর্মুলা, then I have to calculate alpha 2 by
আচ্ছা আচ্ছা
from this vector triangle. A vector triangle, you by using the vector triangle, you have to calculate alpha 2, and then you can use it. So this is not necessary, isn't it? Without using that, you can calculate it. So it is not necessary. You can also, that means this theory is also valid. This is also a valid calculation, but here you do not know alpha 2. And for calculating alpha 2, you have to use the vector triangle, and then only you can calculate. Okay, from the vector triangle, you can definitely calculate by taking the component and. Clear?
P2 sin alpha 2 এটা যেটা ইকুয়াল টু লিখলেন ওখান থেকে বের করতে হবে
Exactly.
তখন ওখান থেকে আলফাটা বের
Exactly. You can calculate. You can calculate.
ঠিক আছে
You can calculate. Exactly. Yes, you are right. From that relation also you can calculate. V2 sin alpha 2 is equal to V2 sin beta 2. From that also you can calculate, and then you can use. But that is not necessary.
তখন
Because,
আলফাটা
huh? Okay.
আলফাটা ক্যালকুলেট করে সেটাকে আলফাটা বসিয়ে তখন করা যেত
Exactly. So you could use that relation also to determine what is alpha 2, and then you can use that in this relation to calculate that. You are right. But that calculation, actually you can skip that. Using this formula you can skip it. So during examination it will be better to follow what is required, what requires the least calculation, right?
ওকে স্যার
Okay.
ইয়েস স্যার
So the next is the power, the resultant thrust. Resultant thrust means basically the resultant of these two, as you can follow. So this is the resultant. So tangential is this, and the axial is this gray one. Therefore, the resultant is the yellow. If I give a yellow arrow, I do not know whether you can see or not. So this is the resultant. So I can enlarge it. I guess you can see yellow arrow. So that is the resultant. Yellow arrow, is it visible? নাকি অন্য একটা কালার দিই তাহলে? এইটা. And now you can see, I guess. This is the resultant. Resultant thrust. Okay. So how to calculate that? Resultant thrust. Can you tell? Resultant thrust. How to calculate that? That is nothing but the, say if I give this a name, say axial thrust is equal to say F in the axial direction, F in the axial direction, say axial. Then it will be basically Fu square plus Fa square. So resultant thrust. So F resultant is equal to square root of these two. What is that? Therefore, 388.89 square plus 287.28 square, that is newtons. So it is coming to be 3899. এটা 89 ছিল না, এটা 97 ছিল. So it is coming to be 3899.57. It was 97. Okay, so this much of newtons resultant thrust.
মানে ভিডিওটা কি অফ হয়ে গেছে?
না তো।
তাহলে আমারই নেটে ডিস্টার্ব করছে মনে হয়।
তুমি আরেকবার জয়েন করো তাহলে কেটে।
হ্যাঁ না স্যার, এইবার এসছে স্যার, এসছে।
এসছে? হুম। Okay,
হ্যাঁ
simply
স্যার।
resultant thrust means basically it's a vector as if there are two components, axial component and tangential component. Therefore, resultant is equal to the vector sum of these two. So vector sum means if they are basically orthogonal, then you can get the component simply by adding the means squares and after that taking a square root. Okay, that is the means component. That means that is the resultant. Okay, resultant thrust
Okay, sir.
magnitude. Resultant thrust magnitude is this, and if you want to determine the angle, then accordingly angle will be basically tan inverse of this and this. So what is the angle made with the angle will be always with the tangential direction. So angle is equal to the angle of the resultant. Sorry. So angle is a delta. Delta is the angle of the resultant thrust with the tangential direction is equal to basically tan inverse of what? FA divided by FU. So tan inverse of 287.28 divided by 3888.97. It is coming to be 4.225, 4.22 degrees. 4.22 degrees. So delta is equal to 4.22 degrees. Next is the power developed. Power developed, and that is 0.4 for the calculation. Power developed. Power developed, we can write power developed as mass flow rate into delta VW multiplied by U, right? That is power developed. So what is delta VW? The mass flow rate, 10, already we have calculated that part. If you, right? This one, m dot into delta VW is FU, already we have calculated. So if we multiply that with U, it will be basically the power developed. So basically it is equal to therefore Fu multiplied by U. So what is that? 3888.97 multiplied by U. U is how much? We have calculated 52.5 pi meter per second. 52.5 pi meter per second. So total unit will be power developed. So it will be how much? Can you tell? What should be the unit?
So what?
Watt, exactly. So basically the unit is meter per second multiplied by newtons. So Newton meter per second means basically joule per second, basically watt. Newton meter means basically joule, isn't it? Newton meter means basically joule. So joule per second means watt. So it is coming to be 641,421.88 watts. Or you can write in terms of kilowatt also. That is 641.4 421 kilowatt or 422 kilowatt, whatever. Okay, power developed. Next, blade efficiency. Last one. Blade efficiency. So blade efficiency is equal to eta B is equal to the power developed divided by the initial kinetic energy. So that is power developed divided by the kinetic energy at the inlet, or rate of kinetic energy, better to say. So therefore, so rate of kinetic energy at the inlet. So since we have done this, I'm not elaborating much on this. So m dot into delta VW into U divided by half into m dot into V1 square. Or you can write this as blade efficiency is equal to mass flow rate cancels. Therefore, it will be basically 2 delta VW U by V1 square. So 2 VR1 cos beta 1. If you calculate it separately, then it will be easy to do. So simply that is already calculated. If you divide that by m dot, then you need not calculate it again. Okay. So m dot is 10. So that means what? Fu is equal to this much. Therefore, if you just divide by 10, it will be 388.89. So that will come easily. So you need not calculate it again. But I'm writing for the sake of completeness. It can be easily written. So V1 plus VR2 cos beta 2 into U divided by V1 square. Therefore, you can write that is equal to 2 multiplied by Fu by m dot basically multiplied by U by V1 square. So what is that? 2 multiplied by Fu by V is 388.89 multiplied by U is how much? 52.5 pi divided by V1 square. V1 is how much? You have determined that V1 earlier. V1 V1 is how much? This one. So V1 can, although we have not determined V1, you can determine. Oh no, you know V1, right? V1 is equal to basically U by this one, right? So basically V1 is equal to U by rho. So basically U by rho, that is U by rho, U by rho square. So U means basically it will be 52.5 pi by 0.42 square. So you can calculate. Finally, it is coming to be one quantity will cancel. One will cancel with this. So it is coming to be 0.8319. Or it is basically 83.19%. Or 83.19% blade efficiency. Okay, is it clear? Is the calculation clear?
Yes, sir.
Okay, so there were 5 quantities that we had to calculate. Tangential thrust, that can be calculated using this relation from this, that is delta VW, and axial thrust can be calculated using the quantity delta VF. Resultant of these two can be calculated by vector addition. Power developed can be calculated from the tangential thrust multiplied by the blade velocity, and blade efficiency is the power developed divided by the kinetic energy at the inlet. Okay. So we can conclude the class here today.
Okay, sir.
Okay, is it clear?
Okay, sir. Yes, sir.
Okay. Okay. Thank you.
Good night, sir.
Good night.
Thank you, sir.
Hmm.